one number 9. And it says the histogram. Remember the histogram, the bars are all joined. If they were separated, that's a bar graph, right? It's really the main difference. And a histogram, you'll always see that on the horizontal axis here, that the categories are joined. 0 to 10, 10 to 20. There's no gaps, right? Okay, so it says it shows the university biology exam marks in Mr. Benjamin's class. How many students scored between 60 and 70 points? Okay, so you go to the 60 to 70 points and you go up and you go across and it looks like it's in the high 30s. You can't tell exactly, so you might use 38, 39, something like that. So that's why I put ISH, 38-ish. If you use 37, 38, 39, any of those is fine. It doesn't hit the line exactly, so we know it's not 40, right? And it's definitely more than halfway. So, what's that?
It's in between?
Yeah, it's in between, yeah. Damien, there's some review questions for you in the print there. Should be, anyway. B, approximately how many students scored between 20 and 60 points? So for that, this is only 20 to 30. I would probably, one useful thing for these questions is I can just go across the top of all of them and just put in a number. And that way if I have to add a bunch of stuff up, I can. So for example, from 0 to 10, I might call that 8. From 10 to 20, I might call that 11. 20 to 30, I don't know, 22. 30 to 40, we said like 38 maybe. 40 to 50, it's slightly more than halfway. I'd call that like 40. No, wait a second. 8, 11, 22, sorry, 28. Okay, 28, and this one would be 30, I don't know, 36. This one, that looks like it's halfway. I'll call that 55. This one we called 38. This one, I don't know, 21. And this one, I don't know, maybe 11 again. And this one, less than half, so I don't know, maybe 3. Okay, those will all be pretty close, pretty close. So approximately how many students score between 20 to 60 points? So I'm going to have to add up this category, which is 22. And this category, which is 28. And this category, which is 36. And this category, which is 55. Or whatever numbers you use. You'll be within 1 or 2 of the ones I used, right? And if you add it all up, I'm not sure. Like 141-ish? Did you get something close to that? 140-ish, that kind of thing? C, why did Mr. Benjamin use a histogram to represent the exam marks instead of a line graph? Any idea why? So there's probably no one correct answer here. You might say, like, there's a lot of students, right? Because it's a university class, like, there's a couple hundred students in there. So sometimes in statistics, whenever we're dealing with larger amounts of data, it helps to group them and categorize them. Okay, make categories. If you only have a few pieces of data, like if I was just doing a class here, 20 marks or something like that, then a line graph might be okay. But I think whenever you have large amounts of data, usually you do some kind of categories to help to make it a little easier to look at. So you might say, because the class was large, lots of students. What does it say in the answer key? Anybody know? Is the answer key wrong here? Yeah, it looks like it's wrong. Oh, so the numbers are wrong here. This is number 9 here. Okay. Yeah, it says there were many students who scored within a range of scores. So it's basically just saying because there's lots of students, really. It's just easier to look at. More useful. And again, with technology now, sometimes if we're not sure what kind of graph to use, if we have the numbers punched into a spreadsheet, we can make graphs like with a couple of clicks, and you can sort of choose the one that visually makes sense. The one that isn't easy to read is not the best choice. So this one works out pretty well. D, approximately how many students does Mr. Benjamin have? You'd have to add up all of those, right? You'd have to go 8 plus 11 plus 22 plus 28 plus 36 plus 55 plus 38 plus 21 plus 11 plus 3. And if you like adding up numbers, then this is a fun activity for you. We'll try it. 19 plus 22, what's that? 41. 69, 105, 160, 198, 219, 230, 233. Did you get something around that?
Yeah.
Close-ish?
233, exactly.
Okay. Again, each bar in that histogram, we estimated the number at the top. But you should usually be within 1 or 2 of what I chose. So in the end, it'll probably be pretty close, right? Okay, number 10, page 13. Tao owns a shoe store. She surveyed some of her customers and she asked them to rate the price, selection, and customer service offered by her shoe store. Why would she do that? Why would she survey customers? Why would you ask customers things like that?
To get criticism on the work that you're doing and where you need to improve things and things that you could fix.
Yeah, exactly. To make your business better so people want to shop, right? Yeah. Customer service is important. I'm dealing with Home Depot now. Not fun. And their customer service has been very poor. I may never shop there again after my experience. I bought a washer, it was no good, I returned it. They don't like you returning stuff. So I'm fighting with them right now.
I don't think all stores like return items.
Yeah, but the whole idea of customer service is like, especially on a big ticket item, is like if you have good customer service, then you build loyalty. The people will, yeah, sure, you had a problem, but it could happen anywhere, right? And if you do a good job, people will want to come back because you solved the problem, right? If you don't, they won't come back.
They go out of business.
Yeah, exactly. But I'm still giving them a chance to fix it. How many customers completed the survey? Okay, how do we figure that out? Would you just add up, are you saying just add up one of the columns? Like add this one up? Okay. So if I added all that up, I'm just going to put a total at the bottom. Again, if you had it in a spreadsheet, it'll do it for you automatically. So 25 plus 38, what's that, 75 or something? 75, I think. Total, yeah. And what do you get when you total up the other columns? Should get the same thing, right? If the customers answered all the questions or gave a rating for each of those things, then there should be 75. I'm just going to double check. Yeah. In real life, if you did this and you added up the columns and you found that like one of them was short, it just means that somebody didn't answer that one, right? They just didn't put a response in for that. But Okay, so 75 customers rated those three things. B, how did most of the customers rate the selection of shoes? Circle the correct response. So we're looking at selection, which is this column, and where's the largest response?
Average.
Yeah, average. Average, so you'd circle average, because it had 37, which was the biggest. More people responded average than anything else. According to the survey, where might Tao's store need to improve on?
Customer service.
So if I'm looking at customer service, 25 people ranked it excellent, 38 people ranked it good, and not too many people ranked it average or poor. So that tells me the customer service is pretty decent.
So
Right.
their prices.
How about prices? 21, so like 54 people ranked excellent to good for prices, and not that many down here. So price is not that
Selection
bad.
then.
Yeah, maybe it's selection, right? Because if you look down here, there's
First
quite
two
a lot.
numbers stand out to me the way that you're explaining it. Makes me realize those first two numbers are important.
Right. So average to poor, there's quite a bit here in selection. So improve selection. So the people like to shop there, they like the prices, they're just not super happy with the choices that they have. They just don't have enough stuff to look through, right? There's stores like that. That's how I like my restaurants. I go to a restaurant, I don't want to see more than one page. Give me 5 or 6 choices. Make sure they're all good. That's great. I hate the restaurants where they have like 14-page menus. The big, like the chains, Boston Pizzas and stuff, they're all bad, right? Or something is good. If you have that many pages, there's no way you can do a good job at everything. I like a restaurant with very few choices. But with shoes, they probably want more selection than that. So D, what percentage of customers rated? So once we're doing a percent, remember you're going to need to divide by some kind of a total, right? As soon as you see the word percentage, you're going to have to divide by a total and multiply it by 100%. That's going to happen all the way through this unit, as soon as you see that word, okay? So what percentage of customers rated the prices at the store as poor? Okay, so that was how many people? 6 people out of 75, then times 100%. So we can just punch that into our calculator. And I got 8%. And then I guess you would have to decide if you ran the store whether that's an acceptable amount. 8%. E, what percentage, again, going to be dividing by something. What percentage of customers thought that the store's customer service was excellent? So customer service, that was 25 people out of the 75. I don't need a calculator for this because 25 out of 75 is exactly 1/3. And 1/3 as a percent is what? 33%, or 33 1/3. Coincidentally, the speed of a long record. 33 1/3 revolutions per minute. Those of you that like vinyl. Anybody listen to vinyl anymore? Vinyl records? No? I'm trying to move into the 21st century. I just got Spotify.
Still use CDs
Yeah, CDs are good.
in my vehicle.
Yeah.
I don't plug my phone in.
I just got Spotify and it's,
It's good when you pay for it.
yeah, I know I'm paying for it. Trying
No, I
to,
don't.
Yeah. Yeah, no ads or anything.
So
I'm
it's
still
not
trying to
the
decide
same
if I like it. What?
It's not the same as vinyl record?
No. With vinyl records, you got to make a choice and stick to it, right? You get the record, you pull it out, you put it on, and it's a pain in the butt to change it. So you better make a good choice. You sit there and you listen to it. The problem with I find with Spotify or that kind of stuff is like there's millions of songs in there, so you end up clicking around
You really gotta figure out what kind of music you're into.
Yeah, you really got to take the time, right? But it's not like an album at a time.
That's why it's like me with my CDs. I have to find certain CDs and certain ones somewhere.
It's pretty good though for if you pick a song that you like, it'll suggest other things you should like. But sometimes it's totally wrong. Like I love that new Lil Wayne song, Uproar. You know that song? That song. So I said I put it in there to see what else it suggested, and like it was nothing. Yeah, it was nothing. Okay, 11. The following chart compares foods that represent the leanest alternatives and which may be sought after by health-conscious individuals. What do they mean by leanest alternatives? That's weird phrasing there.
Talking about meat?
Yeah, it's basically, it looks like they're all meats. And when we talk about lean meats, we're talking about meats that are kind of like maybe healthier, like lower in fat, those kinds of things, right?
Yeah, that's why I get lean meat, so it has like less grease and stuff.
Yeah, and some people are trying to reduce their calories and the fat they take in. Well, I guess that's saturated fat, so they might look for lean alternatives. The problem is, the leaner it gets, you know, the worse it tastes. Like the best tasting meat is a super greasy meat, right?
Mm.
You take out all the grease, what do you got left? Well, the part that doesn't taste like good. Okay, so 8. How many more calories does top sirloin have than chicken in a 100-gram serving? Okay, so all of these are set up for 100 grams. Let's compare them. So we're looking at top sirloin, which is at the bottom. And how many calories does it have? 219. And chicken, I guess, does it only give us that one option? Yeah.
Like me, yeah.
173. So how many more means subtract? So 219 subtract 173. Is that 46?
I got 46.
46 calories. Okay. B. Is turkey healthier than salmon? Explain using the data found on the chart above. Okay. This is a loaded, we call this a loaded term. Healthy is a loaded term because everybody has differing opinions on what healthy is, right? So let's take a look. Turkey and salmon. We're going to compare those two. So turkey's got 157 calories, salmon's got 206.
No, man, turkey's healthier.
So based on calories, turkey is lower calorie. So that might be something you would consider healthier. I don't know. Let's look at the other stuff. Carbohydrates, proteins don't have a lot of carbohydrates. That's your starches and your sugars and stuff. Fats, turkey has 18 grams of, oh no, this is a percentage. 18% by fat, and salmon is 54% by fat. So if you're trying to cut down on fats, it looks like turkey's a better choice, right? Proteins, turkey is a higher percentage of protein than salmon. How about saturated fat? That's the bad fat. Turkey's 1, salmon is 2.5. So turkey's winning in a lot of categories here, right?
Yeah, this is where it gets messy.
Cholesterol, 69 versus 63. So if someone that has to watch, your doctor told you have to watch your cholesterol, well, that's one category where maybe the salmon is slightly better. But in all the other categories, it looks like turkey wins. So you might say turkey is healthier in most categories. If you're comparing them. But it depends on what your version of healthy is. I'd say the healthier one is the one that tastes better. And usually salmon tastes better than turkey. So I'd pick the salmon every day. Okay, C, which food has the most protein calories? So that was the turkey, right? Which food has the least amount of saturated fats? That was also the turkey, right? Oh, sorry, we're not comparing anymore. My bad. I was still comparing turkey and salmon. C, which food has the most protein calories? Okay, let's go back through the whole chart here. Looks like
Canadian lobster.
lobster. Yeah, lobster.
Comparing for the proteins, the lobster has.
All right. Lobster. All right. And which food has the least amount of saturated fats? So saturated fats in actual grams. Looks like lobster as well. I don't know how accurate this is. I thought lobster was fatty, but whatever. It's a chart and a math question. I don't know if it's real or not. Maybe lobster on its own is pretty good. It's just that when you cook it, people always soak it in butter, which causes a lot. So maybe it is good on its own, but nobody eats it that way. Okay, so lesson 2, bias. What do you think the word bias means? Yeah, it's like taking a side, right? And so we all have biases towards like our own preferences, right? Like, I'll argue that Barcelona is the best football team in the world, right? But if I meet someone who's a Real Madrid fan, there's at least one in here. They'll argue the other way, right? So I'm biased towards Barcelona. Yeah. Yeah. So now when we're talking about bias in graphs, that means that the graphs have been changed in a way to try to convince you to agree with the way it's been presented. Okay? Just because it's based on numbers doesn't mean that it's not biased. Okay? And there's different ways to do that, and we're going to look at that. Okay, so the following things are important to consider when looking at a graph. Does it include an appropriate title? Okay. 2, labels on both axes, that's the vertical and horizontal. So they're clearly labeled, you understand what's going on. Okay. They're uniform size, so it hasn't been skewed, like it hasn't been changed to make something look out of proportion. Scale, does it start with 0? If not, is there a break shown? It's truncated. We're going to look at what truncating is. And scale, are the numbers equally spaced? We'll look at that as well. Okay. Example 1. Ralph and Camille are both creating a graph of the amount of aluminum recycled in Manitoba. They each represent the data with a different graph. Okay? So it's the same data, but the graphs look different. So let's compare them. How are these graphs the same? So looking here, they both start in 2000, go to 2010, that's the same. They both track hundreds of tons on both of them. Okay. So they both show the same years. They both show the recycled amounts in hundreds of tons. So at least based on the labeling, they're labeled the same. Okay. How are these graphs different? Okay, so let's take a look. Look at the numbers here. This one goes from 0 to 30, and this one goes from 12 to 24. So that's a pretty significant difference. Okay? So Camille's graph is zoomed in on the vertical axis between 1200 and 2400. So it's almost like this one was on a computer and you clicked on zoom in. You ever do that on a map? You ever had a map application? You zoom in and then you don't see all of it. In this graph, we're not seeing all of it. It's zoomed in. It's not showing all of it. Okay. So this one is zoomed out. This one's kind of zoomed in. Okay. So 3, which of these two graphs are misleading and why? Okay. So which one is the more sort of unbiased, accurate graph? The one on the left or the one on the right? Yeah, the one on the left is better because we actually can see from 0 up to 30, and we see where all these points fit in. This one skips a bunch of values, and what that does is it stretches out the differences. So looking at this, like looking at the left graph here, it's slightly increasing, right? But if you look over here, it looks more dramatic, right? Okay, so this is how we can bias graphs. So for example, if you ran your own recycling company and you were trying to convince, let's say, your funding partners that business is booming, it's doing really well, which graph would you use? Which one would win your argument for you that, hey, things are going up? Yeah, you would use the biased graph because you're zooming in on the differences to say, hey, look at how much it's jumping up. Whereas over here, it doesn't look like, it looks like, okay, it's increasing pretty slowly. But over here, it looks like it's increasing quicker. So by zooming in, we call that truncating, knocking out the 0 down there. It makes it look more dramatic. Okay, we can skew the graph for our own purposes. So which of these two graphs is misleading? Camille's graph doesn't start at 0, so the increased amounts look exaggerated. They look better than on Ralph's graph, okay? 4, how could a business or organization use these graphs to promote its views in recycling? So Camille's graph could be used to argue that recycled amounts are increasing dramatically, while Ralph's graph could be used to argue that it has not been increasing that much. Okay. So example 2, during the annual Winnipeg Job Symposium, Thomas, that should be a comma, Thomas visits booths for companies offering plumbing jobs. A large company that hires plumbers handed out brochures showing the salary increases that a plumber can expect over 6 years. Okay? So from year 1 to year 6. So it looks like a pretty decent jump, right? What's wrong with the graph? So it's been biased. Where should it start over here? What number should it start at? It should start at 0. So this one's been cut and zoomed in. So this is a large company's trying to convince people to work for them, right? And they're like, hey, look at how much your salary jumps up. So they do this little cut graph that makes it look really dramatic. It wouldn't look so dramatic if it was zoomed out back to 0, right? So A, Thomas looks at the brochure quickly. At first he thinks the salary in year 6 is about 3 times the salary in year 1. Because if you look from there to there, it looks like it's jumped up. It's like tripled, right? But it hasn't. It hasn't actually tripled. Because it's gone from like 52,500 up to 72,000 or something like that. It's significant, but it's not triple, right? No, since the graph is truncated, it does not start at 0. B, why might the graph be drawn this way? To try to convince people to, hey, come work for us, look how much more money you'll make, right? What changes need to be made to this graph? It needs to start at 0. Okay. So started at 0, you would actually start like way down here somewhere, and then it wouldn't look so dramatic anymore because you'd have to go down in equal increments. If that's 55,000, if that's 50,000, you have to go to 45,000, 40,000, 35, 30, 25, 20. You'd have a whole bunch of blank space at the bottom, which means it won't look so exaggerated at the top. Okay, example 3. The following pictograph represents fruit collected to make homemade pies for a bake sale. Which fruit was collected the most?
Neither, because they both have the same amount.
Yeah, so each of these symbols represents units of bananas. These are units of apples. Yeah, so when you first look at it, it looks like you got more what? Bananas, right? But it's just 4. How many apples? 4. How many cherries? 4. So just because the symbols have been blown up on the bananas, when you first look at it, it looks like there's lots more bananas, right? So it's been biased. It's been biased. So what was collected the most? They're all the same. Explain how the first graph is misleading. Well, it makes it look as though there's more bananas because the bananas are so big, right? This one's better. This one is quite biased. This one is not biased. Or we can use the word unbiased if you want, okay? Okay, now we already talked about this. Truncated graphs don't start at 0. And what happens is the tops of each of the bars, the differences get exaggerated. So usually if you're trying to win some kind of an argument, you'll use the exaggerated graph, right? But when we're reading math stuff, we want to look at those. We want to look at the ones that don't exaggerate. So these two graphs represent the same data. But this one has been biased because it doesn't start at 0. So it really exaggerates the differences. This one does start at 0, and notice they all look kind of similar, right? Okay, so this is the truncated one. Your test questions will be, is this graph truncated? You just look at it. If it doesn't start at 0, yeah, okay. Truncated does not start at 0. Okay, and then over here, you might see this. Sometimes with graphs, it's okay to do that as long as you visually let the reader know that you've done that. Okay. So ways to properly create a graph instead of truncating. Showing a break in the y-axis allows us to correctly illustrate a graph that would otherwise be truncated. There's several ways to do this. You can have little breaks to show that you've skipped the data. Or the one I've seen more often is like you make a little squiggly line at the bottom. So what this graph done over here to be acceptable is it could have put like a 0 there and then just made like a squiggly line to show that it skipped. Okay. Okay, example 2. The Festival de Voyageurs keeps track of how many people attend the event each year. One of the organizers is concerned that attendance is dropping significantly from year to year. He offers the following graph as evidence of decreasing attendance. Okay, so attendance has been going down, but is this an accurate graph? No, because it didn't start at 0, right? It zoomed in on the differences to say, look how much it's been going down. But if it was zoomed out properly, it may not look nearly as dramatic, right? So has it been truncated? Yes, this graph has been truncated. It does not start at 0. Okay. Okay, and you were supposed to make your own graph. And if you made your own graph, it should look something like this. Now this is very important if you're drawing your own graph. Try to use a ruler, okay, make it nicer. If you have graph paper, that's even better. If you don't, it's okay. It's important that you go up by the same amounts. This is where students make their mistakes. So this is going up by 5,000s, 5,000, 10,000, 15,000, 20,000. You could go up by something else if you want, 2,000, 4,000, 6,000. Make sure that it's always equal. Otherwise, your graph will be incorrect. And you'll notice with this one, the differences are not nearly as dramatic anymore because it's zoomed out now. Example 3. The following graph represents bowling averages of female players. What's Diana's average? So it looks like around 120. This is, you're right, that might become a problem later, yeah. This is a 3D graph, that's why it sort of wraps around here, so it's 120. Who has the lowest average? Looks like Hildy at around 113-ish. How's the graph misleading? Because it doesn't start at 0, it makes it seem like the differences between their bowling averages is really dramatic, right? It really makes Hildy's average look crappy. But the difference is 113 to 120 to 126. They're not that dramatic, right? In bowling, a difference of like 10 is not that much. Okay. And then if you recreate the graph, you'll notice that it doesn't look nearly as dramatic, right? Over here, it makes it look like Hildy's like got almost 0, right? Makes it look like she's got almost no bowling average. But over here, not so bad. Okay, a little off the pace. Okay, that's it. Any questions about that? Pretty boring stuff, eh? Okay. So do the questions, try not to fall asleep while you're doing them. And check your answers as you go. And bring them up if you don't understand something. Okay, let's take a look. So finish assignment 2.